like to start with the dependent variable, although everybody else tends to start with and thinks it's appropriate to start with the independent. I do this because the dependent variable, it can sometimes be pretty straightforward because it's usually the data that you're collecting, the numbers you're writing down. So when we write about experiments, students often forget to describe what they did to collect the data. Students always tell me about the setup. I went and I did this. But then they kind of forget sometimes that you went and did this to collect this data. Let's look at some of these hypotheses here to understand how you might go about testing the statement that corn plants grow taller with fertilizer. You might grow corn in different concentrations of fertilizer, like 20%, 40%, and so on. That makes sense. And then you might record the heights after letting them grow for a certain amount of time. So, what is the data you collected? What did you measure? What did you write down? Yes, the heights of the plant is the dependent variable. This data will allow you to say, yes, corn plants grow taller with fertilizer, or not, as the case may be. Let's skip to the third one. I'll let you think about well, we'll do the enzymes. But what is the data you're collecting on the third one? The jacket I want is cheaper at store X. Hmm, price. Price. Yes, this is what will indicate which jacket is cheaper, the price. So before we do the remaining hypothesis, let's recognize something. Neither of these two hypotheses here tell you that height or price is the dependent variable. You had to think a little bit about that, right? You had to think a little bit about how you might go about testing these things. Keep that in mind for this last one. What might be the data we collect for enzymes increase activity at a higher temperature? Ooh, you might be saying, well, I would measure enzyme activity. I'll take that, but that's pretty vague. What are you what are you measuring? Is there like an enzyme activity probe that we can use that just gives us a number? No, there is not. So, um, we need to get more specific there without really thinking about the experiment. We can't get more specific. So, for example, lactase digests lactose, and glucose ends up being a product of that. You could measure the amount of glucose that's made, right? And that is very specific. That is why defining variables, it can be difficult. They can be vague sometimes. You may have to make a decision of how to test that. My example to students, my classic example is my husband wants to know how many birds nest in our yard. So he goes out and he counts prickly pear cactus. No, that's a terrible dependent variable because birds don't nest in prickly pear cactuses. So my husband wants to find out how many birds nest in our yard, and he goes out and he counts the nests and he gets 12 of them and he says, "We have 12 birds." No, there are two birds to a nest, right? So sometimes you really have to think of the type of data and the conditions of data that you have to collect. Okay, so let's do the independent variables. All right, so corn plants grow taller with fertilizer. I'm not debating this with you. It's just an example, right? What are we testing? You might say we're testing the corn plants. No, we're not. No, we're not. I don't no, we're not testing corn plants. Let's think of what we might do to test this statement. We might grow corn in two different fields and use fertilizer in one and not fertilizer in the other. What are you varying? What are you manipulating? You are manipulating the fertilizer. And this is what we're testing, the effect of the fertilizer. Let's think about the next statement because practice is the way to understand the independent variable. We could use lactase, which is an enzyme that digests lactose, to test that hypothesis. You might put lactase with some lactose in test tubes and in different temperatures and measure something to indicate the activity? What are you intentionally manipulating to be different? Yes, you are correct, the temperature. Let's do the last one. How would you go about testing if store X has the cheapest price? You might go to store Y and Z and A. Listen, I am a master shopper. I don't think that I've bought anything full price since before COVID. So this is a wonderful example here, right? So you might go to 3 different stores and write down the price at each store. You're choosing to go to these different stores. You're manipulating the stores that you go to, and the stores are the independent variable. Let's recognize something here for a minute. Independent variables. You might want to define it as the thing that is being tested. I would stay away from that definition because that statement sometimes leads you to the dependent variable. You're like, this is what's being tested. The height of the plant, the price of the jacket. And this is why you have to ask, what would I be intentionally manipulating to set up the experiment? What do I get to choose about the experiment? I get to choose which stores I go to. I get to choose which temperatures I'm going to test because I can't test them all. I get to choose which corn plants get fertilizer. So the classic definition of the independent variable is what you, as the experimenter, has the leeway to manipulate. Students usually get the independent variable confused with controlled variables. So when looking at an experiment, it is a good idea, even if you have a test question or quiz question asking you about the independent variable, you should also ask yourself, what are the controlled variables? Controlled variables they're usually pretty easy for students to recognize. These are usually, or there are many ways of manipulating them, and they're all constant, like using the same corn plants, the same enzyme, the same jacket. The problem with controlled variables is that they get confused with what is called the control. All right, so the control is different than the controlled variables. Please, 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 please know that right here at the outset. The control is a basis of comparison. This is really hard to define for some experiments. Let's start with the easy ones. We might amend this first experiment with corn plants so that we're growing plants with different concentrations of fertilizer. We'd need some plants grown with no fertilizer as a basis of comparison. So plants not grown with fertilizer here are the control. Okay. Yeah, this one is tough. What do we designate as the control for temperature? 0? Room temperature? Body temperature? You know what? You get to decide a little bit, but you better be pretty clear about why you want to use it as the basis of comparison. How about this? When you set up this experiment, you combine the enzyme with some other goo, and it all starts out at the same temperature. Maybe that's the basis of comparison. I know, a little bit tougher. Are you thinking about a placebo group or a group that you didn't give to drug X to? Yes. Yes, that's the control group. So these can be confusing. When you encounter these concepts in later labs, I urge you to come back to this presentation and review it. Comparing your experiment to these examples can be the way for you to answer the questions. As we went through these variables, the definitions, they don't really help, right? It's the examples that help.